When a program is executed, it is in a runtime state. In this state, the program can send instructions to the computer's processor and access the memory and other system resources. When software developers write programs, they need to test them in the runtime environment. Software development programs often include a runtime environment component that allows the programmer to test the program while it is running. This allows the program to be run in an environment where the programmer can track the instructions being processed by the program and debug any errors that may arise. We assume that runtime storage comes in blocks of contiguous bytes, where a byte is the smallest unit of addressable memory. A byte is 8 bits and 4 bytes form a machine word. Multi-byte objects are stored in consecutive bytes and given the address of the first byte. The size of the generate target code is fixed at compile time. The compiler places the executable target code in a statically determined area named code, usually in the low end of memory. The size of some program data objects, such as global constants, and data generated by the compiler, such as information to support garbage collection, may be known at compile time. These data objects can be placed in another statically determined area called static. Two other areas are placed at the remaining address space: the heap, which stores allocated memory, and stack, which stores activation records generated during procedure calls. These areas are dynamic. Their size can change as the program executes, and they grow towards each other as needed. In practice, the stack grows towards lower addresses and the heap towards higher addresses. We say that a storage allocation decision is static if it can be made by the compiler looking only at the text of the program, not at what the program does when it executes. We say that a storage allocation decision is dynamic if it can be decided only while the program is running. Many compilers use some combination of the following two strategies for dynamic storage allocation. First, stack storage. The names that are local to a procedure are allocated space on a stack. The stack supports the normal call or return policy for procedures. Second, heap storage. Some data still remain long after the call to the procedure that created it. This is usually allocated on a heap of reusable storage. The heap is an area of virtual memory that allows objects or other data elements to obtain storage when they are created and to return that storage when they are invalidated. To support heap management, garbage
Created using Powtoon.